Here's practice 4-5, and we're talking about isosceles and equilateral triangles. So we have to figure out these angle measurements. Well, all of the angles in a triangle add up to 180, and we know about one of them. It's 110. So that means we've got 70 degrees left to divide equally between these two angles, because the arc mark means that they're congruent. So 70 divided by 2 is 35. So they are both 35 degrees. Number 2, we know that this angle is 10 and it's congruent to this angle. So here's another 10. That means this entire angle is 20 degrees. Then down here, we've got an angle here and an angle here. Well, you know what? Why we're sure is 90 degrees, because if this is 90, then so does this. But what about this one? Hey, look, we've got congruent sides, and the angles opposite congruent sides are congruent. So that means if this is 20, then these two angles down here would have to be congruent. So if I start with 180, subtract 20, now I've got 160 degrees to divide equally between my two corners. That means that this one over here will be 80. On this, we have a square. Oops, switch color. We have a square and some equilateral triangles sticking off of it. And what did I just write over? So we need the angle, this sort of exterior angle out here. Well, let's see here. I know that if I start here and sort of move all the way around, I should be able to represent 360 degrees if I start here and consider all of the lines that are getting added up. Well, if I have, let me start it this way. If I just look at this right angle, that's a terrible right angle. Delete that. If I have that right angle from the square, and I include this side from the triangle, well, this will be 90. And from this triangle that's here, this will be another 60. Because since all these sides are congruent, all the angles are congruent, and that would be 180 divided by 3, which would be 60. And I've got another equilateral triangle down here, so I'm just going to copy this angle, which is sort of like this. So there's another 60, and they need to know about this measurement over here. Well, hey, 60 plus 90, that's 210, and it was 360 to get all the way around from one of these angles all the way around to the other side. So if I can account for this this first 210, that means everything else will be this angle that they're looking for. And sure enough, 150 degrees is that exterior angle. Number 4. Well, let's see. We've got sides that are congruent, so that means this angle is congruent with that one. But then we actually have a bigger triangle that's a right triangle. Well, if this angle is 90, and we've got these two that are congruent, then if this is 90, then these two will have to add up to 90. Okay, so I got 180, subtract the first 90, that leaves me with 90, divided by 2. So each of these is 45. So let me just clean that up for a second. So now this is 45, and so is this. Now let me look at this little triangle with the S. This side is congruent to this side, which means that the angles opposite them will also be congruent. So that means this angle here should be equal to this angle here. So that means S is also 45 degrees. Number 5. Isosceles triangle. Angles opposite congruent sides are congruent. And let's see, if this one is equal to this one, then this part out here should actually be equal to this part out here, because they both add up to be straight lines. So supplements of congruent angles are equal. So So 125 out here makes z equal to 125. And so if that's 125, now I've got two angles that are supplementary. So that means they add up to 180. Let me subtract the 125 so I can figure out what x is. This ends up being 55. So that now, let me clean this up. So now with this at 125, this inside is 55, which also means that this guy in here is 55. So now oh, sorry, that looks like a 6. So now since these two add up to 110, that means my final one will be 180 take away 110, or 180 minus 55 minus 55. So y equals 70. Number 6. We've got a regular polygon, which simply means that all of the sides are, from W to X to Y to Z to V. So this shape here is the regular polygon. And that's important to know because if we need to figure out the interior angles in a regular polygon, we have to use n minus 2 times 180, and that equals the sum, and here's the fancy math notation for sum, the sum of the interior angles. Well, how does that come in handy? First of all, how many sides do we have? 1, 2, 3, 4, 5. 5 sides. 5 minus 2 is 3. 3 times 180 is 540. So for the pentagon, that's 540 total degrees, and we have 5 interior angles. So 5 into 540 is 108 degrees for each of these. I wonder how that's going to come in handy. Well, let's see here. Here is an equilateral triangle sticking off the side, so that's cool. So I know that C will have to be 60. Oh, look, here we are. It's going to come in handy. 108, this is just like the setup for number 3. I've got an equilateral and therefore equiangular triangle down here, so that's 60. So I know 60 plus 108 is everything but angle A. So since I'm going to go all the way around in this circle, I've got 360 degrees to account for. So starting with 360, I take off 60 for this, 60 for this, 108 for this, and I'm left with 132. Whoops, sorry. Um, 132 degrees for angle A. Now how about B? Well, let's see here. If we've got this shape in here that's a quadrilateral, then does it look like these two angles will be congruent? Absolutely. Because if this is 108 for the whole inside of this pentagon angle, and I've got an isosceles triangle up here, that means that this angle is congruent to this angle. So that means what's left over down here will be congruent to what's left over down here. So, cleanup time. Now we're looking at this whole thing being equal to 108. But what I know is that I'm going to actually separate off a little quadrilateral and say these are both 108. And since quadrilaterals have 360 degrees inside them, I got 108 here, 108 here, leaving me with 150. Oops. Did I do that right? Yeah. 100. There we go, 144. And this 144 degrees that's left is equally divided between these two angles here. So that means that each of these is 72. So now I've got 72 degrees here and 72 degrees there. Oh, so that means this angle in here will be the 108 from the pentagon, take away the 72 from the quadrilateral. So now I'm at 108 minus 72, and we end up with 36 for B. Now we get to complete the statements. Number 10. AF, A to F is congruent to AD. And that's because this angle, oops, there we go, pen, this angle was congruent to this angle. So we say sides opposite congruent angles are congruent. Now, CA, let me highlight instead. C to A will be congruent to G to A. Oops, I forgot my segment sign. Why? Because angle C is congruent to angle G. And this one would be angle F congruent to angle D. KI would be congruent to KJ because angle KIJ is congruent to angle KJI. Now then, E to C will be congruent to CD. EC was congruent to CD because of the two angles down here that are congruent, so I can just call that simply angle D, but here I have to be specific about angle E because it could also mean this side, so I have to name it CED. CD. Then JA is congruent to, let's see, J to A will be congruent to BA because that angle J was congruent to angle B. And then from H to B will be congruent to BC because the angle H, and I think you know what I mean by angle H this time, so I'll just go quickly through it. Angle H was congruent to angle C. And again, you know that I mean BCH and not any of the other angles at C. So now, a little math for this. Now, they're going to tell us that angle D is 25 degrees. Oh, well, that's cool. So now we have to find the measure of each of these other angles. So JAB, oh, so if this is 25, then that would also mean that this guy is 25. And that guy's 25, because those are congruent, we already knew that. So that means I have a triangle right here, and I need this angle. So I've got 180 degrees in my triangle. I know about these 25 and 25, that's 50. So this angle right here would be 130 degrees. Okay, what else? FAL, F to A to L. Well, if I've got this side congruent to this side, and this side congruent to itself, and this guy congruent to this guy, I've got right angles here, I am very certain that this angle will be congruent to that angle. And since the whole thing was 130, and now I've got this to this to this, I've got 90 here, I've got 25 here, that means this would be 180 minus the 90 minus the 25, 65, which happens to be exactly half of 130. So this is 65. Oop, I didn't write this up here. 130. How about JKI? Well, J to K to I. Guess what? It's going to be congruent to this one here. So I know that's going to be 130. And then D, where's D? D to L to A. All right angles are congruent, so there we go. Now, how about finding some more values here, x and y? Well, let's see. Let's talk about this one, this half of the triangle first. Angles opposite congruent sides are congruent. So this is 55, this is 55, which makes x equal to 70, because I did 180, take away 55, take away 55, and I'm left with 70. So x is 70. Now I get to take that to the next triangle. Oops, pen. X was 70 degrees, so that means this angle right here, vertical angles, yay, vertical, that's 70. Now I've got 70 degrees here, and if these two are congruent, that means this angle with this angle will be congruent. Or you could say that I've got 180 degrees. I know about the first 70, so now I'm at 110. And these two angles would be divided evenly into the remaining number of degrees. So that makes y 55 as well. Just like this down here. 21. Congruent sides must mean congruent angles. Now, we need to figure out a little bit about this one by this angle pair, this linear pair. Two angles that make a line add up to 180 degrees. I know about 110. That leaves me with 70 for x. Then, what do I know? Well, let me clear this up. If x was 70, this is 90, that leaves a little bit left over here. So out of 180 in a triangle, I know about this 70 degrees and this 90 degrees, and that leaves me with 20 degrees for angle y. How about 22? Last one. It's a square. So this means that angle will be congruent to that one. And down here, I got another right angle, so this will be congruent to this. And if this is a right triangle with these two sides that are congruent, that means these two angles are divided evenly among the rest of the angles that I don't know. So out of the 180, I know about 90. That leaves me with 90 degrees to divide evenly between these two. So y is 45, and so is this one. Now, if this is a right angle, and I've got this side congruent to this side, and that kind of matches up with this side congruent to this side, and this side congruent to itself, this is actually an SSS situation. Side, side, side. Which makes all the other parts, congruent parts, corresponding parts of congruent triangles are congruent. So it makes all the other parts congruent too. So that means not only is y 45, but so is x.